Welcome back, everybody. The battle continues. It's time to take one more bite out of this elephant. We have got so many tasks on this bench that we are just going to make room and peck away at them one at a time. And it might seem like we're doing things a little bit out of order, but trust me, I do have a work plan. So what I'm doing right now is getting all of the belt pulley drive components front and center, because don't misbehave here. Come on, there we go. Stick with the others. Because we're going to need to have this unit ready to go before we get into this unit. All right. In the end, it should all make sense. So work that's been done so far, aside from it being completely disassembled for years and years already, I cleaned up the housing and did a good glip towel coating on the inside. And I also hit this opening right here, even though it's technically on the outside. Once the pulley mounting flange goes on, that's going to block me from being able to get any primer or paint on there later. So I just wanted to have something covering that surface. Now, the construction of this and design is pretty much the same as a production 445 belt pulley drive. The main difference is in the design of the casting. So where this one flares out around that pulley flange, the production one, as you can see here, tapers down and the flange is entirely outside of it. Barring that difference, everything here is pretty much the same. So there's really nothing to compare and contrast. This is a 10X 4101 casting. And one interesting design feature is that hole with what looks like a Pegasus wing having been etched off of it. That is an oil catch. So the bowl gears and everything run in there, and that's just meant to channel any oil that may have splashed up onto the housing down into that feed hole, and it gets in the passage here between the bearings, keeps everything lubricated. And regarding the old bearings, everything was just worn and pitted enough. I decided it was time to go all new. This belt drive unit really doesn't look like it's done a lot of work over the decades, but that one is getting pretty rough. Yeah, rollers are loose. It doesn't really like to spin anymore. So luckily, the bearings and the races were all Timkins, very common sizes. We've got excellent new parts to put everything back together with. To begin, we've got two snap rings that need to go into the housing first. We got one groove right there, and flipping it around, the other groove is down there. And these snap rings are what back up the bearing races. Each one is the same size, looks just like that. So we'll see if we can make one fly, right? Compress it just enough to go in. One down. Come on. That groove is in there somewhere. There, we found it. Check them both out. Yep, both looking good. Now that both of the backstops are in place, we can put the races in. Should be able to tap these in because I tapped the old ones out. Some of you might say I'm using this driver backwards. That's because the taper on these has never been great to match the taper on the bearings, so it wanted to put marks in the face, so I just turned it around backwards and used this kit like that ever since. All right, down on the bottom, that one's fully seated. This one's fully seated too. Now we can load bearings onto the shaft. So this bearing down here is going to have to transition 2 different press fits. We've got the first one right here, and then it'll fall down, and then we have to press it onto the second spot down there. And I turned out this quick press adapter so that I can just push upon the inner race and not put any pressure on the cage or the rollers. It's not pretty, but it's good where it counts. Good tight fit so far. There it is. Now we're ready to place the housing onto the shaft and the first new bearing. And before we can put the oil seal in here on the outer end, top end, as we're looking at it right now, we need to press this second bearing down in, because once we put that seal in there, we are not going to be able to push this in, and there won't be enough shaft sticking out to start the pulley flange and draw it all together. So it's kind of a roundabout assembly. That's the only way I've really ever found to do these. There, I think we're seated. I didn't want to press it on so far that I started getting a ton of preload, because I want to set that when I tighten the nut. Yeah, it's a setup. Okay, everybody, I know it doesn't seem like it, but it's actually been a little bit better than an hour since we pressed this top bearing in. So the next step was going to be putting the oil seal in. And this is one Senior bought, I bet, better than a decade ago. It said X231 belt pulley, so I took it out of the box, and sure enough, it fits. All right, so we've got a good seal for it. But I was just fitting the pulley hub first, and I noticed something that I'm glad I did before I got the seal put in the way. So the way this is supposed to work is the face of this hub will press on that bearing, and as you tighten the nut down, it squeezes the bearings together. You get your preload. One thing I noticed though, when you slip that onto the splines, press on it just a little bit, it sticks on, and it should not. There we are. That means that something is not fitting properly. So I started looking at it really close, and I noticed we have some, you see that indent right off the end of the screwdriver? We'll get it in the light. Okay, you can see it really well from this angle. You see that square cut in on the tip of that spline? Another one right there, another one right there. Those should be flat across the face. So what's happening is the depth of the hub does not match the depth of the splines on the shaft, and because the low points of these splines taper shallower as they get to the bearing, that means the tips of the splines on the hub are binding on those before the hub is actually pressing on the bearing. And if we can't press on the bearing, we're not going to have preload, and we're actually going to develop some slack that's going to make that oil seal leak and throw our gear mesh off. So it's the prototype nature of this tractor. Everything is, it's close, but it's never quite right. So I had to make a decision. We need to get pressure on those bearings, but I didn't want to grind on the splines on the hub because I don't want to set this into that housing any further than it already is. We need to stand proud because of the way it bolts up to the pulley. All right, we don't have enough room to actually set that down in. And incidentally, X231 did not have a belt pulley on it when we got it. We just had the drive. So Senior, again, like better than 10 years ago, picked up this 445 pulley. It's actually got like Jetstar Brown, but they all use the same one. That's that 10A7098. Same pulley across the line, and this fits the drive perfectly. So I decided to make a washer. All right, we've got this. I had to cut some teeth in it to match those splines, but that is a spacer that is going to rest on the bearing. And now we can set the hub on there. See that? It's free floating, and it just sets us up a little bit more above the top edge of the casting, which is good. Plus, it is not going to cause any problems with the nut and the fold-over lock. And yes, X231 actually used some fold-over locks. I know if any of the Caterpillar guys stuck around long enough to actually watch this part of it, which I appreciate it, guys. Yeah, here's a couple fold-over locks from X231. This was from the PTO gear that's in the back of the transmission right now, and I have not remade that yet because we're holding off on making anything permanent back there until we get this sorted and that sorted. So we do have to make a new PTO fold-over lock, and the belt pulley version is just a little bit smaller around, but they did it kind of funny on these. They gave it 6 teeth on the inside that would engage with those unused splines, and then the nut would go on, and then you would fold it up onto one of the flats and call it good. The production tractors did not use these straight nuts or fold over locks. They actually used these nylock style nuts, and you would run that down and then it would self lock and hold in place. But we don't do that on X231 because X231 was pioneering their foray into fold over locks. So the fact that we have set that hub up a little bit higher is still not going to hurt, because here's the material I'm going to make the lock out of. If I can do this while holding the camera, just gauging it, if we sandwich that down, all right, we still have full purchase on the threads that stuck out. So that is going to work out just fine with that spacer behind this drive hub. I know this stuff gets awfully tedious, guys, and I apologize for it, but it's all part of prototyping this stuff out. Old X231 just doesn't ever give you anything at all for free. So I'm confident enough now we can finally get the oil seal put in. A little bit of grease on the lip there, all right, and finish off the stack with the hub. Start it into the seal. Very good. Okay, so now we get to try our hand at making the fold-over lock. I've never made one like this before, but I think I know how I'm going to go about it. And as long as we're doing the one for the belt pulley, let's do the one for the PTO as well, because the inside features are the same. It's just that they're a little bit different diameters. So several ways to go about this once again, but I'm going to cut the 2 round blanks out of the steel first. So I have 2 different size hole saws. The ID will closely match the OD of each lock. So let's get 2 circles cut out and then proceed from there. Well, come out of there. Doesn't want to play nice. This one's just made for X231 right here. Look at that. Yeah, I've got a bad feeling about you. Okay, so with one of the old locks clamped on top of the new blank, I'm using this 27/64 transfer punch because that seems to follow the contours of the areas between those legs just perfectly. So we need to mark out 6 holes on center for 27/64 between the legs on the inside, and we'll see how well it turns out. Six dots in there. So as I drilled my pilots, I had both of the blanks bolted together, so that acted as a transfer, and I got them both done at the same time. So you're only marking once and drilling once. So now we just take them out to full diameter and then see what it looks like. All right, I think we did it. Faithfully recreated both of the fold-over locks. Of course, the PTO one, slightly bigger around than the belt pulley one because the belt pulley lock cannot be any bigger than that hub. Otherwise, the pulley itself would not go on. But despite the wear, I believe I have pretty accurately recreated the tabs that are on the inside of each one. The belt pulley lock was quite a lot harder to get much detail from because that thing had run loose for so long. Oh man, it was really in bad shape. But I'd been procrastinating on this PTO lock because it just didn't look like anything that'd be very fun to do. But I have to admit, I don't really like this lock design. Of course, I'm pretty biased for the Caterpillar locks because they have a pretty positive retention system. So the way these work, those 6 tabs, if you rotate it right, they will fall down in the exposed ends of the splines like that, all right? But there's quite a lot of movement in both directions before they actually tighten up. And in a perfect world, you don't want to have any movement at all. So when we tighten the nut down, it is going to want to carry this lock clockwise with it as it tightens in. So we'll get it all happy, we'll fold it up. But then the lock could still allow that much movement on the nut before it grabbed in the counterclockwise direction and really started doing its job. Although if it's folded correctly, it'll only allow just that little bit of movement, and then in theory you won't have anything after that. But these definitely left me with the most interesting looking scraps too that I've ever had after I finished a couple of locks, a couple little stars there. So we've got another one for the archive box. Let's get this finished up. Book spec is 15 inch-pounds rotational torque, and I've rebuilt enough differentials in the last 20 years to know I am in the neighborhood. Nice preload, good and smooth. That's where we keep it. Some fold-over lock footage for all the lock fans. Yeah, that'll work. So we're finally ready to put that stubborn belt drive into the back of the tractor here. But first, if you all remember back to the line boring job, step 1 was to true out that bearing bore that we just proved out last time. Step 2 was to face mill all of that repaired area, and we mimicked all of the contours that the production tractors have. But you can see how far we had to cut in, how much material we had to remove, how close we got to where that bearing sleeve is. And this mimics the contours that the production tractors have back here. Of course, X231 was all broken out in this area, and that sleeve had been spinning and all the other trauma that had happened in there. As we guide the belt drive in, just take note of how close that gear comes to all of this. It is a pretty tight fit in the housing. It is meant to self-align to a certain extent. And as we guide it in, look at how close that gear comes to the contours of that bearing bore. It actually goes inside of the gear teeth. It's crazy how tight they made these tractors back here, but it's going to work. Okay, everybody, to finish things up, let's just do a little bit of housekeeping. We'll get that PTO gear lock put on. I've just had this heavy washer under the nut. For the time being, holds everything all together. Find the splines. That seems all right like that. Nut back on. See if we can't get everything all lined up here. Okay, we'll go like that. Very good. Now I hope everyone can see why I wanted to get this gear in place to go with this gear already being in place, so that we can start fitting that shell in there and mesh with both, and that's just all part of the process. This is going to stay like this with no gasket or anything beneath it, because they shimmed these out with gaskets to set the gear mesh and everything inside. Looking at the production parts diagram, 6 and 7 are both gaskets. Number 6 says gasket housing thick, quantity 1. 7 is gasket housing thin, varies. So you just put in however many you need. And we opened up a little bit of space on the bench. That, well, next time it'll be something here. It all needs it. The belt drive was going to be a first half of video thing, and then we would move on to something else. I don't know why I still surprise myself like that, because I should know by now it's never that easy. Thanks for watching, everyone. Hope to see y'all back again.